purpose of this video is for you to be able to just to define important terms within a star's life cycle. First is a nebula, and the nebula is the big cold cloud that is the birthplace of stars. It's predominantly made of hydrogen. There are lots of other gases in there, like there's some helium, and in modern times there's trace amounts of like methane and other elements depending on where the nebula came from, but it's still predominantly hydrogen. Now, a protostar is something that's going to become a star. It's a certain mass of hydrogen that will eventually be able to get hot enough in its core to fuse hydrogen, where a brown dwarf is like a wannabe star, where it's something that doesn't ever get hot enough because it doesn't have enough mass to become a star. Now, the next term is fusion, and fusion really is when two atoms collide and stick together and convert some of their mass into energy. The most common type of fusion going on in the universe, and the one that we're most happy about, is hydrogen into helium. And that's what gives all the stars their energy, this process. Now, main sequence. A main sequence star is something, or a star that is fusing hydrogen in its core. These stars are all main sequence, regardless of the fact that they're different in size and in color. The color denotes the temperature of the surface of the star, but the fact that they're main sequence means they're all fusing hydrogen in their core. Now, another way to, or not another way, but a way to discern between stars is to talk about their absolute magnitude and their luminosity. And these are both descriptions of how bright the stars are. These are both things on how bright the stars are. I don't know if I repeated myself. I tried to pause it, and I may have made a mistake. I'm sorry if I did. Now, a red giant is a star that's in its later stages of its life, where its core has run out of hydrogen, and in the process of running out of hydrogen, the star's core collapses, gets hotter, and therefore is able to start fusing heavier things like helium into lithium. And this process gets the star to fuse elements outside of the core, and then the star tends to swell into this. Carl Sagan once called it a grotesque image of its former self. It becomes huge, and that's why they're called red giants. An older star that's in the latter stages of its life. Now, the next two things are like a black hole, and a black hole is something that, a place that in the universe that can't withstand its own gravity. They're often formed when really massive stars destroy themselves, and in the center, the core becomes a black hole because it can't withstand its own gravity. Now, a supernova is when big star, after its core runs out of hydrogen and is really predominantly iron, stops fusing, and the core collapses in upon itself. And when it's done collapsing, for some reason it pops and blows up on itself. And this explosion is a supernova, and they are kind of a rare cosmic event, but they're really important for us because they're the reasons we're alive, because they create supernova, or what populates the universe with heavier elements, things past iron. And that's what a supernova is. Now, the last things are stellar remnants. Now, a stellar remnant is like a bones of a body. It's what's left behind after it's died to a certain extent. Even though bones will eventually go away, these things won't technically go away. They will, unless something comes along in like a black hole or something, or we find a way to withstand incredible gravity. these things will not go away. And this is like an example of somebody's bones, Dr. Square, his bones. First of these things is a white dwarf. And a white dwarf is basically, this is a smaller massed star's core. And it's extremely hot, extremely dense, and it's like a big lump of matter, and that's just what it is. It's kind of simple in a way. And a black dwarf is what a white dwarf would eventually become, and you wouldn't see a black dwarf because it's black. And a neutron star, and I don't have a picture of it, but a neutron star would be very similar to a white dwarf, but it would be a ton smaller, and it'd be a ton more hot, and it would rotate a lot faster. And they're also known as pulsars.